Hey folks, thanks for having me. This is not my first AJUG. It turns out if any of you were here about 12 or so years ago, I presented for the group and I learned some really good lessons about preparing for a presentation, which is why I actually prepared ahead of time this time. There are a couple hours to go before I finished all my slides. I felt good about that. But yeah, around 2004, I was talking about how we were using Flash components backed by Java, enterprise Java components on the back end, and bundling them together. And we thought that was going to be the next big thing. Turns out we weren't quite right about that, but let's talk about microservices. So thanks for having me back. I appreciate it. And you'll notice my first slide talks about angst, the madness of microservices. So we're going to talk about some good, we're going to talk about some bad, we're going to talk about some real world trials and tribulations with microservices, how we work past them, and some of the lessons learned from that. And we're also going to talk about software architecture in general, because I don't think you can talk about a specific architectural pattern like microservices in isolation. It's helpful to put it in context with other things. So let's begin. Yeah, that's kind of redundant. So this is me. I am a co-founder of a software consultancy called Cambium Consulting. If you are interested, we would love to talk to you about big data, AI, functional programming, Elasticsearch, and fintech type solutions. Moving on. What are microservices? Wikipedia is the authority, right? If it says it on Wikipedia, that's the answer. So let's talk about these points. Loosely coupled. Folks agree that's kind of describes microservices? Problem is we don't have a strict definition here. It's kind of a fuzzy thing. Fine-grained, lightweight protocols, probably present. Yeah, like JSON, everyone pretty much uses that nowadays. There are a couple binary formats that come around, but the idea is with microservices, applications are easier to develop and test. Would folks agree with that? Disagree? I'm going to be picking on you a lot, so get ready to interact. I'll single people out too. Parallelization of development. I really like that one. We're going to talk about that one again. And I forgot to turn on audio. There we go. A little boost. Is it better with or without the mic? With the mic? Hey! I'm glad I'm sharing everything with you all now. Microservices can help enable continuous delivery. Do folks believe that? Disagree? Agree? Show of hands. Who agrees with that? Who's had some challenges there? Cool. That's an interesting mix. So I'm going to go ahead and say that I think writing loosely coupled microservices is hard. It's not something that's easy. You don't just say, hey, I read this blog article. I'm going to adopt microservices. I'm going to write loosely coupled microservices. How do you do that? So let's talk about that a little more. But let's first start with some history. Nice little history lesson. Anyone here developing in the 90s? Anyone know people who have developed in the 90s? All right. You remember the 90s monolith? If you were working in Java, you were working on WebLogic. Java, it was J2, was it even J? It was like J1 EE. It was early Java Enterprise, and this thing in the back end, that was Oracle. This was most of your main options here. And if you had workload that spanned more than one server, you had a pool of application servers there. You had some challenges though, right? We typically don't write software like this anymore. Why is that? Session state. Where was it stored? What happens if a request came into another server? Where would it go? Sure. Yep, there are ways to deal with it. Ever had trouble with sticky sessions not quite being sticky enough? Yeah, pretty much everyone has who's tried that pattern. So there are trade-offs, and that is what I'm going to focus on more on this talk than anything else, is that no pattern is a panacea, and every pattern has trade-offs. Anyone tells you anything different, they're trying to sell you something, and they're doing a really bad job at that. That's another opinion. Anyway, sticky sessions, you've got other state that you might need. You could always stick it in the database, right? What's the problem with that? Yeah, if I need to do a bunch of quick auth checks to know if someone has access to something, now I've got to go through my full stack to get there. But how long did that walk through the full stack typically take? Probably milliseconds, hopefully milliseconds. If it was larger than that, then you might want to redesign a few things. But typically, requests were taking the order of hundreds of milliseconds at a time. And so that could provide, if you look at user experience design and things like that, someone's expecting a responsive application. We weren't really expecting that responsive of applications back then, but we would have liked them. And what happens with a couple 100-millisecond calls for a couple minor things is you end up having a second or two delays for the user, and the user experience seems clunky. People are going to feel it's slow at that point. So here's another option. And about 6-7 years ago, I designed a system just like this, where you start to, if anyone's familiar with the CQRS pattern, it's very similar to this idea. But in essence, you're separating out your gets, you're mutating calls, your puts, posts, and deletes, your writes, your things that change the system from your gets and retrieving the data. And there's a cool feature back here, you see master and read slave, where you have your database needs to support when a change happens to the master, and only in the master, it propagates those changes out to read slaves. So we start to hit this problem, like with the Vencat videos earlier, of eventual consistency, where things will show up eventually. You're going to have a little bit of a delay between that write to the master and the propagation of the read slaves. But we're also seeing this change in database technology really empowering that type of model, this new type of architecture, by having a system that will automatically propagate changes out to read slaves. And I'm calling it an HTTP-aware router. You need a front-end piece that can say, what type of request is this? Goes over there, goes over there, goes over there. So one thing I've identified is, and a question I have for the group is, why are we not seeing more smarts in that router space, in that really front-end space? You've got typically round robin, you've got a handful of other patterns in your application-aware router, but the big players are doing something very different at that layer. Remember SOA? Is SOA cool anymore? It's not cool anymore. You're not supposed to do it anymore. Why not? That's what I expected. Most people don't know the answer to that question. Yeah?
It's fine, the implementation of it for it, because we put a lot of smarts into the bus, and so now you can move the monolith into the bus instead of maybe the applications over.
So the comment was, the implementation of SOA, the way it was actually implemented, was what hurt this architectural pattern, because people put so much logic into a shared bus, and now your monolith became the bus. Is that? I think that's a reasonable assessment of some of the pushback against it. There was such a push to do SOA, you had to use an enterprise service bus. And if you didn't, you weren't doing SOA. And the fact of the matter is that's not quite true. And I want to come back to this pattern because I think this pattern might actually have legs if we ditch the ESB. Anyone recognize this pattern? It's why we're all here, right? Microservices. It's the thing you're supposed to do. You never get fired for buying IBM is the old adage. Did you ever get fired for deploying microservices? Maybe. Depends on if they work. Because what the end user cares about is a system that works. So what are some advantages to this style of system? What do you see any advantages from the architectural diagram?
Independently scalable units. Microservices are independently scalable. They can be polyglot. All kind of.
So independently scalable, polyglot, different languages for different services. I could have service 5 be written in Scala. I could have service 2 be written in Java. I could probably even have service 1 written in Node. That's a thing now, right? Can I say that as Java user group? JavaScript. It's close, right? Same thing. Oh, almost. Anyway, you have some advantages to this style. What are some disadvantages? What are some challenges that you might have implementing this style?
Traceability, like for example, in logs or something, any request you want to catch up, it's hell, we don't know where the request goes.
Yeah.
Unless you have taken care of it ahead of time.
Traceability and logging, those are good concerns. Blue in the back. Inter-service dependency. This is a good crowd. I feel people here are writing real software. Yes, inter-service dependencies. Do you mean libraries or do you mean other services that are dependent? Other services, was that? Yeah.
Service A calls B, B calls C, and so on. One of them goes down.
Yeah, A calls B, B calls. Have you read my slides? It's giving away a few things coming up. But transaction management. All right, I think I'm done here. This crowd really knows what. That's great. I'm going to talk about that too.
You have remote versus local calls if you want to compare it to a monolith. So you're going to have performance issues possibly.
Performance. Whereas at a monolith, we had remote calls, and now with microservices, or we had local calls. With microservices, we have remote calls. Okay? I think these are all reasonable challenges. In fact, I'm going to talk about each of these. Yes? Security, how so?
Securing the API calls between the microservices, making sure that one service calling the other one is a secure call, all else.
Okay, so securing your calls between your microservices. So I can definitely see that. Typically when I see folks doing these types of things, they've already adopted cloud deployments and it's all in one VPN in a single cloud. But you have issues with that too and availability. In fact, one of the systems that I'm going to talk about here, remember when S3 went down in 2016 and like most of the internet went with it? Yeah, that was a bit of a challenge. So having a cross-cloud solution could be advantageous. Also, best practices recommended for high availability, even within a single cloud like AWS, is to distribute across availability zones and maybe even data set and maybe even like separate areas of the country. So there you might have some more security challenges because I don't think you can maintain with AWS the VPN across different areas of the country, but I could be wrong. Does anyone know the answer to that? All right.
Same region, but you can cross availability zones, but not across regions.
Yeah, that's what I thought. Awesome. Thank you. Yes?
Versioning, release management, compatibility metrics.
Thank you. Thank you. Yes, versioning. How do you handle versioning when I'm going to switch to the next slide because, no, I'm not. I'm going to talk about it first. Let's say you have services calling one another, and I'll show a diagram of this apparently in a couple slides. I must have moved that around. But anyway, let's say service 2 and service 3 both have requests coming into them. They depend on service 4, but they need service 4 to do slightly different things. How do you version service 4 and the calls from service 2 and service 3? How do you deploy all those at the same time in an eventually consistent system? So you're not going to drop data coming in. You're not going to drop user requests. These are challenges. Cool.
Things also, I think, is the data model. I mean, because it's totally different than what we did back in the monolith days. Because now, you're using NoSQL, you're using maybe SQL in some cases, but what's the relationship between those? So what's the canonical view of the data model in the domain? That's a big challenge, I think.
So what's your name?
Ron.
Ron brought up data modeling is different nowadays, especially with the advent of NoSQL data stores, which are often very prevalent in microservices and more modern architectures. And I agree the data model plays a role. I'm not sure. So the difference, in my opinion, between your more modern NoSQL stores and your more relational stores, which are coming back again, it's like bell bottoms, they'll come back in style, don't worry about it. It's not a lost investment at all, really. But a lot of the major difference there is where can you see the definition of what the data model is, and can you be fuzzy with some of the pieces? You can be fuzzy in the NoSQL stores, but that can bite you in your code, and it bites you so quickly. I don't know if that's always such an advantage. Maybe it's an advantage when rolling the pieces out so you don't have to do a database migration, but can your Java code, your JVM-based code really handle multiple data models in the data store? Maybe. Maybe only if your changes are additive. If not, I doubt it. So let's move on a little bit, and I'm really impressed with all of the parts from the crowd. So I want to zoom in on this one particular piece you might see highlighted on my slide. Can anyone see the words that are loosely coupled? How easy or hard is it to create loosely coupled services? So I think requests, in my practice, requests to highly microservice-based systems where you've heavily broken down the domain end up looking like this. I end up processing through a couple nodes in service 1, one node in service 2 and 3, a node in service 4, 2 nodes in service 4, a node in service 5. They each have their own independent data stores. Some could be SQL, some could be NoSQL, but they're independent. But this is one request, and one request is part of a larger feature. And so when the product folks come to you and ask why you need a maintenance window to deploy changes to a particular feature, and you show them a picture like this, they might have a few questions for you. So let's talk about when things go well. Things go well, I'm creating something, and part of creating that, I have to get something else. I have to create something else, and part of that creating something else, I get something else, I get something else. Now return back created, HTTP, everything's wired together. Life is good. Everything works well. What happens when it doesn't work well? What happens if this one little thing times out in there in the middle of that? As folks have already pointed out, suddenly I have a distributed transaction problem. And so I open my microservices book and I look for how you solve distributed transactions. It's right under crickets. There's no answer for that right now that's any different than we've had for many years. And for many years, folks working on the Java platform especially, we've had a distributed transaction framework that you could kind of count on and kind of couldn't. One really nice feature of JEE back in the day, J2EE when I was using it, was there was a transaction notion built in, and if a sub-entity was not able to be created, EJB created as part of an entity creation, it would roll back the whole thing. And it needs support in the database to do that. But I thought we were talking about NoSQL stores. Do they have transactions? Some of them, but not all. I've worked with one that does, but there are some challenges with rollback as well. So I'm not saying I have all the answers to these problems. If anything I want to get tonight, and it seems like a lot of the audience already is aware, so maybe I'm preaching to the choir, is for folks to start to think about these problems before they adopt a highly microservice-based distributed system. Because if you don't think about these problems, they're not going to go away. They're going to come up in production, and we'll talk about that too. So this is my quote. I quoted this. Microservices, we've taken something that used to be a couple of function calls and added many, many points of failure. So think about every single call off box, what happens if it fails, and does your code allow for that? So failure, it's a hard thing, right? How do you handle them? So let's talk about some techniques for handling failure in distributed systems. For starters, that slide I put up with the HTTP calls, which a lot of people use for microservices. Typically, it's either HTTP or you're breaking off into queues and messages at some point. But either way, you can, with HTTP, you can propagate errors back to the caller. With that example that I showed, and I might even dive back to it real quick. Yeah, with this example that I showed, that 408 ended up failing creating the post above it. And so I got a failed dependency callback. And that lets the caller know, I was almost able to create the thing for you, but one of the dependencies went down. So what do you display in the browser when you get that? What do you tell the user? You can figure it out, you can code it into your system, but there's a lot of logic to code in there. You might need to include a richer error return with that HTTP response. Probably need more than just the error code. Failed dependency, well, do I try it again? Do I not try it again? How do you write your code? These are common distributed system problems that were not around as much during the 90s monolith days. So as uncool as that architecture is, there were some trade-offs that we weren't quite having to solve there. So let's talk about an error queue or an error service. I know any of my services have an error, they'll tell the error service that they had an error. Or they'll put a message in the error queue. It seems funny, but especially when we're talking about asynchronous messages instead of HTTP, or even implemented with HTTP that and calls that return right away and do an asynchronous piece of work. One error queue to collect up where the root of the error happens, or an error service to figure out where the root of the error happens, might not be such a bad call. Yes, in the blue.
Well, that sounds fun, but what if you have a chain of calls that depend on each other?
Yes, just like in my slide, I showed a chain of calls that depends on each other. What happens there? So when you start putting error messages on a queue or using an error service, whatever's processing that error queue or the specific error, standalone error service, there you're going to want to put some logic in to try and figure out the root cause. Because that's the biggest challenge I've seen with these heavy microservices systems, based systems, is we were aggregating logs in a service called Papertrail. And what we had to do was click on the errors and jump into the Papertrail log and then scroll up to the top. And hopefully we found the top or the root cause of that issue, and that's how we knew. With something like an error service, and I haven't tried this particular pattern, we really just scrolled up in paper trail. And the part of the problem was we ended up having to scroll a long time sometimes especially once the system got under load. It was nearly impossible to find the root cause of what ended up going wrong and just the cascading amount of failures that would happen in these systems. So there's challenges around tracing back to that root cause. And anything you can do ahead of time, any thinking and design and architecture you can do ahead of time to make it easier to identify the root cause of a request that went awry, that's going to pay dividends in one of these types of microservices-based architecture. Gosh, we're just talking about identifying what happened when things blew up. Imagine writing the code to recover the error. What would that look like? Yes, in the back.
Maybe call another copy of the service that failed.
Yeah, maybe call another copy of the service that failed. So let's say you're calling into service 3 and it fails. On that call, you get a timeout. Well, that may not be the only node. And if you look back in our architecture diagram, that wasn't the only node. Like service 3 has 3 nodes. Maybe call back. So a retry could happen. If you're using something like Kubernetes and pods, you might have multiple services running in that pod, multiple instances of that service. Call back in again. Maybe you'll get a different answer. Or is that the definition of insanity? I don't know. Anyway. That's a good technique. In fact, retries are really common in distributed systems such that is anyone familiar with the term idempotency or idempotent? It got popular probably 6-7 years ago. Yeah, was it popular 20 years ago?
I was a tuxedo guy.
All right. Well, we have a gentleman in the front who was ahead of his time. 20 years ago, he was doing idempotent services. I don't know too many other folks that were doing that, but I applaud you. That's great. Idempotency. So being resilient in the face of retries. So we're typically looking at CRUD or REST type modeling of the world, though things get a little more complicated than that with create or with puts, posts, deletes, and gets. Which of them can you make idempotent?
Put.
Yes, in the back.
Okay.
The puts or the updates and inserts.
Updates and inserts. So how do you make inserts? What was that? Post is not idempotent. Well, so get, put, delete can be idempotent, but not post. Anyone disagree with that? Is it possible to make post idempotent? I believe it can be if you're generating IDs on the front end.
Why would you use puts if you're generating IDs on them?
Because you haven't actually created the thing. You've just created the ID for the thing.
You can use a put to create.
You could. Again, I don't have all the answers for your particular system or whatever particular system you're thinking about, but these are questions you should be asking yourself with microservices and large-scale distributed systems. So there are techniques for making converting posts or creations to puts and or making post idempotent, depending on your point of view. Would you agree with that? Okay. Yes?
Are you defining idempotent the same way that I understand it, in that it doesn't change state? Because a delete by definition or a post or a put by definition changes state.
So I'm defining idempotent such that multiple calls with the exact same data do not change the system. So only one of those calls. What was that? Yeah, only one will mutate the system. You can mutate the system, but if you have blips in the matrix and you see the cat twice, Nothing happens.
I guess maybe I'm thinking
Nothing more.
transparent then, right? Hey.
Yeah. Well, maybe. I'm. Yeah. In any event, did you think about these things before you went down the microservices path, or even a distributed systems path in general? So, back to those points of failure. What errors could be recoverable? One way to recover is by, I'll ask again, can anyone hear me? And perhaps, retries are the way to go. Are there any other patterns? Yes?
Giving a default answer, a best guess, caching.
So caching, giving a default best guess, which in essence is like a static cache per se. I kind of think of it, I kind of think of them as a similar pattern in that, let's say I was working on a voter registration system that I'll go over shortly. And let's say you have a file that describes all the election authorities for the state of Pennsylvania. And that election authority file gets updated. You go to an election authority service that pulls up that data for that particular piece of information, and it doesn't get the latest data. Could it use a cache file that you deployed the service with earlier in that day or last week? Yeah. And is it as good? No. But it might be good enough for your particular use case. So caching slash default data can be a really good technique. In fact, we used it in the system that I'm going to talk about shortly. Any other patterns? Yes, sir. Circuit breaker. Can you describe that for me, please?
Yeah, for example, you're getting a lot of errors, then you cannot prevent your system from, you provide like a fallback mechanism, so downstream, or you don't affect other systems from any cascading failures.
So the idea that you've described with the circuit breaker, and the way I understand it, is if one system out of 5 in your request path has an error, it stops the system that called it stops maybe back propagating errors?
No, it's about the fallback calls.
The fallback calls.
Yeah, Histrix has a fallback mechanism.
It doesn't tax your system and doesn't bring the whole system down, rather than that whenever you see huge number of errors happening for one URL, you will throw another message.
It may not be applicable for the system down issue, but something else happens within the system, some error, some SQL error or something comes inside, then it will, instead of throwing that error, there is a default fallback mechanism which gets triggered.
Yeah.
And it's like a catch block for that system. So,
but importantly, it opens the circuit and stays open for a certain period of time, so it won't even try the suspect again.
Okay, so in this case up here, how would a circuit breaker help?
say in your case of reading from the cache than from the service, right? The default fallback mechanism will actually, for those GET calls, don't go to the service, just load from the.
Oh, so if a couple calls fail to the downstream service, it might stop calling the downstream service? That's where the circuit break happens?
Say the GET site API piece file, that request timeout, okay?
Yeah.
So it's a GET call. So I can write a fallback for the same GET API. And I say like, okay.
Oh, maybe go to a different service or something.
No, read it from the cache.
Oh.
Local cache.
Ah, got it. Okay, cool. So I've heard the term, but I guess I didn't really fully internalize the whole circuit breaker pattern. Do folks feel they understand that from what they heard?
So there's one benefit of the circuit breaker is when you mentioned Kubernetes, right? Kubernetes has readiness and liveliness, which is the health check. So as soon as your circuit breaks, like Histrix, the error code returns is 403. And then your Kubernetes is looking at the pods, hey, if everything is available, and one of us started returning 403, I'm going to take it out of the system and I'm going to scale it up to the new one. So what happens is, and the fallback mechanism that you just explained is, step 1, do something, timed out. Step 2, can I do anything with it, which is fallback. If it fails, then I'll try to revise the transaction somehow. If I can't do, I'll just return an error.
Okay. Okay. Did folks hear that? Kind of? No. So if I can repeat correctly, let me know if I get it wrong. With something like Kubernetes, you have active and readiness and liveliness. And if something is performing well, returning positive error codes, positive status codes, everything's good. If it starts returning like 403s, then it'll have a fallback specified. And it sounds like that fallback could be to spin up additional nodes.
So there are two kinds of fallback we're talking about. One is that you can put a fallback in the code.
Mm-hmm.
Which is write a method that does something, a resource specific thing.
Mm-hmm.
The resource specific method fails, the circuit breaker breaks, and the circuit breaker within the same code will try to see if there is a fallback mechanism for my circuit.
It's a service level fallback.
Yeah, exactly. That's a step one. But if let's say the code cannot recover, the step to fallback is Kubernetes is going to start receiving the errors that even the fallback failed. And now Kubernetes is going to say, okay, is the node level problem, it's no longer a service level problem.
Okay.
So the node itself is kind of not available.
Cool. So to paraphrase a little bit, you should be, if you're going to use one of these architectures, you should be paying a lot of attention to your orchestration framework and your orchestration tools and what facilities those give you. And you need to think about these problems of a distributed transaction or certain calls failing midstream and how your orchestration is going to allow you to handle that and perhaps even recover. So that's great. And when I was working on the system, Kubernetes was a little low in the adoption. We were using Fleet, and that was awful. It did not do these things. But let's go on a little more. I've got some funny jokes too. So James Erie, I love this quote by him. I like to quote it like every presentation having to do with distributed systems whatsoever. But some people, when faced with a problem, think, I know, I'll use distributed computing. Now they have n-squared problems. And this is so true. As soon as you start to expand the number of your boxes, your difficulties grow at least n-squared. I'd even say n-cubed. There's a lot of good solutions that have been coming out around orchestration, and you should pay heavy attention to those. And I would not venture down this path without a really solid orchestration solution. So I've started talking about it a little bit, but I love talking about real world examples because I'm just some guy up here in front of a computer talking about things and talking about my opinion. What do I know? That starts to get anchored a little bit more in reality when we talk about specific instances of things that have happened. So I like to go over some of those details. I've hid the identities of the parties to protect the innocent and the guilty, but we'll talk about some things that happen. So fall of 2016. The 2016 election was approaching. Does anyone remember the 2016 election? Was it kind of a big deal? Is it still? Maybe. So I was working for a small nonprofit, and we were trying to help get people registered to vote. Probably a good thing, right? The company before I joined had a lot of difficulties in previous years with a monolithic system that they had built. And so they said, we know what to do, microservices. So we were looking at a system that was kind of designed like this. It was a little different, but this will give you the idea. And so I think we're looking at about 16 services right now. In reality, it was closer to 30-something. I joined after the architecture was solidified. So if we were going to change a notification, collect some new user information as we were developing the system, and create a new notification, these were all the services we touched. an approximation thereof. So how do we deploy those at the same time and not drop any data requests coming in? What was the plan for that? We needed to change the election authorities. One service. Total bonus, right? We didn't have to touch anything else. That's the promise of microservices. What about adding a new partner? What about adding a new voting method? So this one was cool. We only had to touch one service. What about the rest of them? And so when you're thinking about making changes to a highly distributed system, are you only making additive changes? Can you? Did you get your model right so that you can only make additive changes in the future? If not, you've got 16, 32, 64, I don't know how many services sharing data in a certain way, and they might speak a different format at some point. How do you roll those pieces out? You almost want to ask for a deployment window, but that's not cool anymore. Microservices. We're supposed to be able to deploy these things hot and not allow any traffic to drop. You got to think about some of these problems and trade-offs. So my notion is deploying multi-version services. Let's say service 4 from my slide before. You could call into it version 1, version v2. You have 2 endpoints. That's great. You make some changes to some of the back-end logic for it. Did you test both endpoints? Did your test cover that? Have you made sure? What about version 3, version 4? How many versions are you going to get in before you're likely to have broken one with a new change with shared logic and shared code? What about some libraries it depends on? Challenges. We ended up having to drop back to maintenance windows to get some of this stuff out the door. Luckily, there were not a lot of people registering to vote at 2 in the morning. I would have liked to have been sleeping. But, you can do that after the election. So there were some nice things. Sometimes, as you saw, we can make changes in isolation. That was good. When we were working in a single code base, changes were easy. I didn't have to wait 10 minutes for my test to finish running against that code base. The tests were relatively quick against a single code base. And sometimes one team's work did not conflict with another. But if we look at this general design, sorry, be jumping around so much. If we look at this general design, we had things like scheduling messages. The scheduler was a separate service. We had things like sending out an email was a separate service. So what happens if a bunch of people are registering to vote and they're trying to get an email at the end, and you have a partner doing a major media blast notification email out? You could easily flood one single email service, even a cluster of it running. How long does it take to send an email? Usually 5-6 seconds with the stuff we were using. To get responses from external services. I'm sure you can do it faster. We did not have that figured out then. But just this notion of you could have one service starve, or one set of features end up starving another with such a highly distributed and broken down problem here. Is there another way it could have been designed to avoid starvation? Let's think about that. I'll talk about it in a few minutes. So we had some nice things. Challenges, as I've spoken about a few times, destructive changes to the initial model, probably going to happen, definitely did with us. What happens if there is an error? We try and scroll up in our aggregate logging fast enough to catch it, or we had to let it go. Tuning. I haven't even spoken about performance much yet. But in this type of system, your average requests were about 4 to 5 seconds. We've blown way past the 200 milliseconds or 250 milliseconds threshold, maybe 500 that people, like 1 second is typically for user experience considered you can't go past that. That's the farthest you can go as far as making the user wait. So we had some challenges. How isolated are my services from one another? How much do they depend on each other for requests? Features and performance. I suggest treating performance like a feature. Build that into your user stories. Say, I would like to have this person's election authority looked up, and they should not have to wait more than 1 second. Put those as acceptance criteria. It can inform your architecture and your design. I think it's a very powerful thing to do. And there's almost always an implicit requirement there that someone hasn't written. So I say make them explicit. And Docker is often extolled as a great way to be able to work locally or remotely on some of these services. But I want to pose this question out to the group. Using Docker Compose, if anyone's used that for running your local services, is it really faster and easier to use that to spin up 30 services and work with them than to work with a monolith? Have you thought about the CAP theorem? Are folks familiar with that? All right, not too many folks. So consistency, availability, and network partitioning. If anyone has managed a Rabbit MQ cluster, you are familiar with these 3 things, because you've probably seen that cluster fail in each of these individual ways. Especially network partitioning seems to be a common one. The network partitioning is, I don't know if I have a cluster of 3 nodes, the nodes can't see, one of the nodes can't see the other 2 anymore. That's a network partition. So it doesn't know if it has the answer or the others have the answer. It doesn't know where it is in this stream of transactions in your distributed system. So I encourage everyone to become familiar with the CAP theorem. It's kind of cool. I'm not going to spend a ton of time going over because I'm taking a little longer than I thought anyway. So what saved the bacon on this project was the single page application that could asynchronously sync to the back end. So people would be typing information in, and we were using some technologies and libraries such that they could go to the next page, they could go to the next page, and it was saving state in the browser, asynchronously posting that state or updating that state to the back end, and you didn't have to wait for a response. The answers would come in when they were ready. And where you did end up having to wait for an answer, we were able to get enough information a few steps ahead of time so the user didn't notice the 5 to 6 second wait until they got to that next part. You had to move really fast through the application. None of our users were moving that quickly through the form-based pieces in the voter registration system. So that really saved the bacon. And I'm a much bigger fan of these single-page web apps. But there were 2 parts of it. There was the single-page web app and the ability to asynchronously synchronize that state with the backend. One thing to note is as the user load grew, and it grew really a lot bigger than any of us thought, which was cool. But the queues just started backing up. And we just had to make bigger queues. Like, we tuned it and we cleared some things up so each of the services got better. New Relic was super helpful. I wish I included it in the slides. A special shout out and thank you to New Relic. Because Without their tools, it would have been really hard to tune all these different services. And I want to say that perhaps instead of creating a general purpose service, what if we think about a library? What if that scheduler wasn't a separate service that everything funneled through and completely got backed up under load? And you wrote your schedule as a library such that every service itself that needed a scheduler ran its own copy.
Is that kind of like an anti-pattern? Isn't that what they say microservices is actually completely against? Having dependencies I mean, if you're doing that, you're basically going back to the monolithic way of doing stuff.
Cool. So the comment was, isn't that an anti-pattern for microservices? Doesn't that mean you're going back to monolithic? I don't think it does, but if it does, I'm cool with it. I liked the 90s. There was grunge. There was some cool stuff. Yes? Excuse me, folks. I can't hear her. Yes, again?
So when you say that you are going to convert it to libraries, but say, for example, if there is a change in that library and your 10 other microservices are dependent on that, so you are going to release that 10 different microservices again?
Best questions ever. So the comment was, that's cool. You're going to depend on a library. But what if you have 5 services that depend on one library and they have conflicting needs? Fork. Use GitHub. Press the fork button. That's how it's managed.
I think she was also saying that now you have to deploy 5 microservices because of a change that wasn't in their business logic.
So the opposite, where the library changes, well, do you have to deploy those new microservices? Maybe. Maybe not if they don't need those changes to the library. So you have a library management problem. We have a lot of patterns for dealing with that. We've been doing it for a lot of years. I'm not saying that there's a silver bullet to it, but I'm saying the patterns are well established and we know how to handle a lot of these problems. And yeah, so the comment was just upgrade to the version of the library that your service actually needs. We're starting to be more independent stovepipe services, which was one of the main tenets of SOA that was eclipsed by the adoption of these enterprise service buses. So that's why I say let's look at some of the stuff in context and history. And here's my radical idea that I proposed to you for microservices. Instead of fine-grained services around specific facilities like a shared email server, what if you align your services around the features that get delivered to your clients, to your customers, to the people using your software? What if the microservices better align with what gets delivered to the end person than how an engineer thinks about breaking down the problem and sharing the pieces on the back end? What if we move some of the shared infrastructure problems, when applicable, into libraries? That we might have to version, but better solve that than rolling out new versions of 5 different services at the same time. I could be right, I could be wrong. Think about this. And as you can tell, I like the conversation. I like the feedback. One second. The other piece to this is I suggest organizing the teams around those features. Instead of having the email server team, the notification team, the scheduler team, have the voter registration team, have around a larger scaled service or feature that gets delivered to the client or the person. Yes, in the blue.
I was wondering if you have an example.
Yeah, so I tried to give 2 there. That was a little weak. So let's see if we can beef those up.
We actually are implementing it this way.
Okay. Can you tell me more?
Yeah, we are in a supply chain company. teams. So we have warehouse management and transport management, and we have broken that complex logic into smaller functionalities, like inbound functionalities, outbound functionalities, and then the parcel, how online orders are managed. So all those, like around the functions or the business problems that the client needs, we have created microservices around those functional areas. And then the basic architecture, we are providing them as libraries, and all the components use the infrastructure as libraries.
So I'll try and illustrate. Could you hear that? Probably not. I'll try and illustrate the example, but you said in the supply chain industry, and they've structured services around what gets delivered to the client. So
the notification, the email, all those are like common for most of the
notifications and emails are common. They're all in libraries that the services use that are around delivering something. Like you might have a trucking service or a handful of trucking services that are all around the trucking and delivery of things to people that might share some common things with others, but they do it through libraries. Maybe you have a shipping one too. Would that be a good example? And that would be a separate service, and they share code only through libraries, and they don't share common services. So shipping doesn't bring down trucking delivery. The two can never happen. And your demarcation around your service boundaries and your deployments are more along the lines of what your customers need than what your developers think they should be.
Bounded context, right? Functional bounded context is what.
It's called functional bounded context. I did not come up with it. Yeah. Yes. Sorry. What was that?
You're alluding a little bit to domain-driven design there. That's a better way to think of microservices.
Okay, I can't say I felt I fully dropped what domain-driven design is, but I guess now I do. It's great when you derive a concept that everyone else is like, yes, it has a name, here you go. Perfect. There are no new ideas. And my wife is also a director of product management, and so I hear a lot about the pains that product has dealing with development. So I just wanted to focus on that idea of maybe instead of, as developers, we think so much about some ideal way to break down the problem from an engineering standpoint, and we just focus more on what needs to end up getting delivered to the client and the customers, that we might end up with better system demarcations in our distributed systems. Who's familiar with Conway's Law? Now everyone's familiar with Conway's Law. You can all raise your hands now if you're still awake. All right, anyway. Organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. So I would argue that if you do domain-driven design and you set up your system around the features that get delivered to the end customers, that your teams are going to naturally organize around those. And instead of having a notification team, you're going to have a trucking team, you're going to have a shipping team. You're going to have everything organized around what gets delivered to the end customer. And that's where I see microservices being a huge help, where you can split off, where you have larger development organizations and teams. Maybe you have one team of 10 that works on this product. What happens when you have a team of 200? There's no way they're all going to work on the code together. No one wants that. So how do you start to split it up? And this is what I suggest is a better way of doing it. So some benefits: avoids deployment conflicts between your teams, and versioning is less of a problem. Shared infrastructure handled with libraries. I've probably beaten that over folks' heads enough times. Some drawbacks: potentially missed optimizations. So it's a good thing Google didn't take this approach with Bigtable. They have one shared team that runs Bigtable within Google and other shared services that they provide for folks. And they version them if they have to, or The other teams have to get on board with whatever that specific service is offering at this time. But there are folks that do not do this approach and have been very successful. See, I'm not trying to sell you something, because I'm showing you the opposite of what I've just suggested, and obviously at very, very successful companies who have done very well with their technology. And there's some teams may end up having to host more service instances than they would want to. So let's say you have a database team managing a data store. Let's say you have a notification team. Let's say you have a scheduler team. Well, in theory, to write this new product, I don't have to host as many services. I just have to host services around serving that application logic I need, and I use these other shared resources out there. And at large scale, some folks have pulled that off. And you might too. Or you might not. It could be confused with SOA, and SOA is a bad word now. So I'll go over one more quick case study, and then I will try and wrap this up. Sorry, I'm running a little longer than we planned. If someone needs to get a hook, let me know. It's cool. No hook. Sweet. So email archiving. So this system, we were able to efficiently manage petabytes of data. Petabytes. It's such a fun word to say. You only deal with terabytes? No, petabytes. Terabytes could be ingested per day. Account-based co-location or sharding. So I'll talk about this a little more, but we were running hundreds of nodes in EC2, ingesting email and sticking it up in S3 and other places. We had some other techniques there. And we had a lot of nodes dedicated to search, too. That was like the killer feature. You could take your enterprise with Microsoft Exchange, and within 72 hours, I think you could have all your email ingested and searchable across your enterprise, which could be very useful if you were ever getting sued, as well as a few other use cases. So one of the ways that we kept that sane was the system could allow you to co-locate as many accounts as you want or as few accounts as you want on a specific cluster. And we could manage clusters at a time. And the largest cluster we had was about 25 nodes. So it was a little easier to keep track of things, but we had a lot of DevOps folks, so there was a bit of a trade-off. It looked something more like this, where you'd have these adapters for different things, ingesting data, putting messages in queues. Worker nodes would pick up the data when they can. They would process it and stick it up on S3. So, a couple nice things. All the code was present on every node, including the adapters. So forget about libraries. It was one large code base. It was a monolith, I think. Node's role was determined by configuration. Reuse was super easy. Just call the function. It's right there. It's in the code base. System ran across hundreds and many hundreds of nodes in EC2. We made heavy use of Elasticsearch, and updating large Elasticsearch clusters can be challenging while they're running heavily. Elasticsearch is awesome tech. We love it, and we actually do some specific consulting around it. But there can be some challenges to managing it. 400 to 500 EC2 instances. Any idea what that bill looked like? Anyone have a guess? I can't tell you, but yeah, all right. Still might be cheaper than managing your own hardware. Right now we're working with a client that manages their own data center and their own hardware, and they're replacing drives all the time. Full test suite did take a while to run. You could run specific sub-test suites in areas you were working, but if you wanted to make sure you couldn't have broken anything else, then you had to run the full test suite, and it did take a while. So are these microservices? I want to pose that question because we've got these worker nodes and these adapter nodes. They may have had the entire code base, but they were doing very different jobs and running through very different execution paths. Could you look at them as services? It's a nebulous definition, who knows? Luckily, we've talked about a framework for evaluating these things and evaluating if the architectural patterns might actually meet what you need. So, just to go over that definition again, we've spoken about some concerns around loose coupling, fine-grained, lightweight protocols, having applications that are easier to understand. Is that always true? Sometimes. Parallelization and helping with continuous delivery. I think we've spoken about all these challenges tonight. And so I think that microservices are very powerful. I think that there's a number of problems that they're good for, and that number is much smaller than what mainstream might have you believe. I don't think there's a silver bullet to software architecture. I think it's another pattern. It's something that's good for some things, that gives you certain trade-offs, and there are different ways to slice the domain and to organize the problems. And I think people are still figuring this out. We still, as a community, are trying to figure out what are the most effective ways to use microservices, and what ways maybe should we stay away from. Whenever you're talking architecture, it's trade-offs. Fun slide at the end. Thank you for having me. I appreciate the time. Anyone? Did I scare the hosts off? Hosts! All right, now I will dance until the hosts return. Oh, no, you don't want to see that. What do we got?
Yeah, I'm just curious.
Oh, questions. Sorry. Questions. Let's take questions.
I'm curious what the audience would feel about an architecture that shares a common database platform that has functional applications that service a particular function. Would that be microservice?
So the question is, what if you had microservices, but instead of stovepipe services, you had a shared database? Does it look like this?
Essentially, I mean, with that 90s monolith, right? Each application server is just replicated across. So that same service is on each server.
Yeah. So with this concept, instead of these being the exact same nodes, these might be different services. So you might even have something more like this, but they all point to one database in the back.
Right. Especially when you talk about reporting and trying to give the business what they want. All these databases, they're going to be a pain in the ass to get.
So when you move on to reporting requirements, the person talking about this is saying that it can be really hard if you have all these separate databases to meet those requirements. I didn't even talk about reporting. Thank you for bringing it up, because reporting needs are almost always orthogonal to your main application needs. They almost completely always fly in the face. And I've seen so many teams get caught up in proper application design that even really meets their domain well. And then what about reports? And just the music halts. No one's dancing anymore and they're looking around. Yeah, I've seen this happen way too many times. So the person who's speaking about this mentioned that, what if you just use one database? So I'll ask the question, what are the trade-offs to that design? And I think the trade-offs are, you've got a lot of the power of microservices, but you've got a lot of the power of the data aggregated in one place, and you've got a single point of failure, a big, fat, giant single point of failure in your application. And when we were trying to scale stuff in the 90s, the database was always where the buck stopped. But there's some really cool distributed database systems now that can help you solve some of these problems.
I'll argue the other way.
Yeah.
Where they live is an operational decision. If your operations people say, I can put those 6 on a piece of hardware, and your platform knows nothing about it, awesome. If they later decide to move that to 6 or to 2, awesome. That's not an architecture problem. It's a deployment problem.
So this gentleman says it's not an architecture problem, it's a deployment problem. I have trouble seeing a difference between the two because every large-scale system I've worked at with a separate ops team has just wanted to shake the developers and say, did you think about how I needed to do my job? So I have trouble separating the two, but to your point, if you have an ops team that says, yeah, go for it. One server, I'll give you an IP address. You just write to there at this endpoint. And
You're missing the whole point of DevOps.
Okay.
In the DevOps model, this is what your logical layout is. In a DevOps model, your database administrators may look at that and go, I can give you better performance, I can give you better replication, I can give you better X, Y, and Z if I can put 2 of those on the same physical machine. Likewise, your nodes on the left, is that one VM cluster? Is that one Kubernetes cluster? Is it 10? Is it 30? That's an operation, that's a deployment discussion as part of what you're building, not the architecture. If you said I have to have a separate Kubernetes for each of your services, you did it wrong.
I'm arguing that it's an open discussion between both teams.
Countering your don't do one server, you can't back it up, you can't replicate it, your single point of failure argument. I'm countering that as in the DevOps world, you can come up with a solution that's appropriate for your budget and for your people.
I think we're actually arguing the same things where I was talking about some of the newer database technologies. Look at those because they might look like a single instance and give you all the goodness that you want as far as your replication, your availability and scalability guarantees.
I think the problem isn't necessarily.
But good point. Sorry.
Yeah, I'm sorry. No, it isn't necessarily the single point of failure of the database. It's more of a single point of constraint or agility because if you're adhering to some data model, then you're going to really have a difficult time modifying your microservices in a lot of cases. That requires a schema change. Of course, there's other databases out there that can.
So what happens if you have a relational model in that single database and you need to roll that out and your microservices? Can you roll that out within deployment windows or within a reasonable time frame so you're not dropping requests? These are really, really good points to consider. From now on, I want to call a single point of failure a single point of agility. That's beautiful. That's great. Thank you. Oh, let me in the back.
Think about it is that if you have a microservices using this particular database, one of the things you can do if you're streaming that data is to tap off that data stream into another service that captures this data and puts it into another data store that is modeled around the reports that you need. So you create another data store to actually do that. By tapping, you're actually getting a copy of the data that's being transacted in those key areas. Without taking a penalty of actually having to run a report on an online database or having to worry about managing all these others. You're actually taking that data, capturing it from that tap stream and storing it in a way that's meaningful for the reporters.
So the comment was, don't worry about reporting, don't create a single database for reporting, tap all these data stores and
tap the streams that are feeding the microservices.
Oh, the initial microservices themselves. Before the data is transformed, maybe even tap up here and just save that off in a reporting data store.
Another way to do it is also using Kappa, or using a Kappa routine where you're actually using like Kafka, right? This data already stored up. Why not replay the stream into another service that actually captures that data and stores it in the
So Kafka is awesome tech. I love it. It's distributed log. It's log for distributed systems, and you can just replay the log somewhere else. You could bifurcate that log and play it into your reporting data store as well as your application data store, and life is good. I think that sounds like a good approach.
Look at, in that case, look for K-string. If you are using Kafka, and then if since I work with Spring, we have a through Spring string, you can actually simplify that K-string development.
Okay, and it sounds like with Spring there are some libraries to help you simplify it. That sounds great. You are introducing more hinges to your system, more points, potential points of failure as a trade-off. But if I were to design a system from scratch for most business applications I've seen, I would look to use that exact same approach. So I'm in big favor of what you just said. Yes?
Are we creating like more loopholes to the security because of this kind of architecture? So like database, if someone has to hack a database, it will go at one point, but if your data is flowing like in flows, there are 4 points to get your data.
Yeah, so security, you've just added more hacking points. Congratulations. Now you have n cubed problem. I don't know how many problems. Yes, that is a concern. And if security, so one of the ways you improve security is you reduce the number of pivots or hinges or levels of indirection in your system. You also compartmentalize things. So that's where I would say with security concerns, I would start looking more at compartmentalization. Well, is all that user data or what aspects of that data are really the ones that need to be protected? Maybe those can go off to a different place and get joined with some type of foreign key type, some type of external ID between these systems. And I put extra security protections around more of that private data. There are some different techniques, but it does increase your security concerns as you increase the number of systems.
And encrypt every response object, what you are doing.
What was that?
Just encrypt the response object of each and every response service.
Yep, you could just encrypt the response object, but how did you distribute those keys to the client? Anytime someone talks about encryption, like it's cheating, because all I have to say is like, how did they get the keys in the first place? That's the key. The distributing the keys, the initial secrets, is always been the challenge that we have not solved with security. But yes, if you can distribute the keys in a safe manner that you feel comfortable with on the client, then you just encrypt the response and you're good. Additional questions, comments?
So how do you, when you have one database, it's difficult to individually test the services. I wouldn't even like to call a database for microservice, it's data store, data stores.
Yeah, sure. I like the term data store better too.
So that's bigger compromise that would be like difficult to test independently.
So the comment is, how do you test things independently when you have one large shared data store? Good luck. You have a giant shared ball of mutable state. How can you test anything and feel confident in your tests? You can't. And that's part of one of the impetuses for moving to separating out some of the data concerns into separate data stores that back each service. That was part of why we got here. So, sorry, I don't have the perfect answer for you, but that's definitely a trade-off you should look at. Anyone? So, thank you for having me back, Atlanta. I appreciate it.